It is my pleasure to welcome Dr. Andrew Wu tonight. Andrew is the Managing General Partner of AI Fund, founder of Deep Learning AI and Lending AI, chairman and co-founder of Coursera, and an adjunct professor of computer science here at Stanford. Previously, he had started and led the Google Brain team, which had helped Google adopt modern AI, and he was also director of the Stanford AI Lab. About 8 million people, 1 in 1,000 persons on the planet, have taken an AI class from him. And through both his education and his AI work, he has changed numerous lives. Please welcome Dr. Andrew Wu.
Thank you, Lisa. It's good to see everyone. So what I want to do today is chat to you about some opportunities in AI. So I've been saying AI is the new electricity. One of the difficult things to understand about AI is that it is a general purpose technology, meaning that it's not useful only for one thing, but it's useful for lots of different applications. Kind of like electricity. If I were to ask you, what is electricity good for? You know, it's not any one thing, it's a lot of things. So what I'd like to do is start off sharing with you how I view the technology landscape, and this will lead into the set of opportunities. So a lot of hype, a lot of excitement about AI, and I think a good way to think about AI is as a collection of tools. So this includes a technique called supervised learning, which is very good at recognizing things or labeling things, and generative AI, which is a relatively new, exciting development. If you're familiar with AI, you may have heard of other tools, but I'm going to talk less about these additional tools, and I'll focus today on what I think are currently the two most important tools, which are supervised learning and generative AI. So supervised learning is very good at labeling things, or very good at computing input to output or A to B mappings. Given an input A, give me an output B. For example, given an email, we can use supervised learning to label it as spam or not spam. The most lucrative application of this that I've ever worked on is probably online advertising, where given an ad, we can label if a user is likely to click on it and therefore show more relevant ads. For self-driving cars, given the sensor readings of a car, we can label it with where are the other cars. One project that my team at AI Fund worked on was ship route optimization, where given a route that the ship is taking or considering taking, we can label that with how much fuel we think those will consume and use this to make ships more fuel efficient. Did a lot of work in automated visual inspection in factories. So you can take a picture of a smartphone that was just manufactured and label, is there a scratch or any other defect in it? Or if you want to build a restaurant review reputation monitoring system, you can have a little piece of software that looks at online restaurant reviews and labels that as positive or negative sentiment. So one nice thing, one cool thing about supervised learning is that it's not useful for one thing. It's useful for all of these different applications and many more besides. Let me just walk through, concretely the workflow of one example of a supervised learning labeling things kind of project. If you want to build a system to label restaurant reviews, you then collect a few data points, or collect a data set where it say, the pastrami sandwich, great. They say that is positive, servos is slow, that's negative. My favorite chicken curry, that's positive. And here I've shown 3 data points, but if you're building this, you may get thousands of data points like this, or thousands of training examples, we call it. And the workflow of a machine learning project, of an AI project, is you get labeled data, maybe thousands of data points. Then you have an AI engineering team train an AI model to learn from this data. And then finally, you would find maybe a cloud service to run the trained AI model. And then you can feed it, best bubble tea I've ever had, and that's positive sentiment. And so I think the last decade was maybe the decade of large-scale supervised learning. What we found starting about 10, 15 years ago was if you were to train a small AI model, so train a small neural network or small deep learning algorithm, basically a small AI model, maybe not on a very powerful computer, then as you fed it more data, its performance would get better for a little bit, but then it would flatten out, it would plateau, and it would stop being able to use the data to get better and better. But if you were to train a very large AI model, lots of compute on maybe powerful GPUs, then as we scaled up the amount of data we gave the machine learning model, its performance would kind of keep on getting better and better. So this is why when I started and led the Google Brain team, the primary mission that I directed the team to solve at the time was, let's just build really, really large neural networks that we then fed a lot of data to, and that recipe fortunately worked. And I think the idea of driving large compute and large scale of data, that recipe's really helped us, driven a lot of AI progress over the last decade.